Every day we use AI agents. We ask questions, generate content, write code, and solve problems. But have you ever wondered how does LLM decide what to do? How can a LLM create a file or interact with a computer? Today, we are going to understand the foundation behind these systems. We will build an AI agent that will communicate with LLM model, understand user request, decide when it needs a tool, execute actions on the computer, receive the result, and continue the conversation. The interesting part is we are not even using huge framework that hides everything from us. We are building the core idea ourselves. Once you understand this foundation, frameworks like LangChain, LangGraph, and other agent platform becomes much easier to understand because you already know what is happening underneath these systems. By now, you probably know how to open and use the notebook from my GitHub repository. If not, no worries. Just check my previous videos on how to do it step by step. Let's head over to my GitHub repository. Then click on AI Assistant Computer Control folder. Here, you will find AI Assistant Computer Control Notebook. Copy the notebook URL and then navigate to your Google Colab account and click on File, then Open Notebook, click on GitHub and paste the URL here. You now have the notebook saved in your Google Colab. Now let's start T4 GPU by clicking the Connect T4 button on the top right corner. Before we start building our agent, we need three important capabilities. The first one allows Python to communicate with the computer. For instance, show me all files in this folder or create a new Python file. The second one allows our program to communicate with AI model. This is how our Python code can send questions to LLM and receives answers. The third one is to help us securely access our API keys. Instead of writing our keys directly inside the notebook, we keep it safely stored and retrieve when it's required. So these imports are basically give our AI assistant three capabilities: computer access, AI communication, and secure authentication. Now let's look at the configuration section. This part contains the main setting of our AI agent. We are using OpenRouter API with Llama 3.1 8 billion instruct model. Next, we are creating our LLM class. This class represents the brain of our agent. When this class starts, it prepares everything required to communicate with the AI model. It creates the connection, it remembers which AI model we want to use, it stores instruction that defines how the AI should behave. For instance, we can tell AI, you are an assistant, you can use the required tools. Whenever the user asks you to create a file, use the computer tools. These instructions becomes the behavior guide for our agent. Next, we give the system prompt. The agent follows simple workflow. Understand the user's request, decide if tool is needed, execute the action, read the results, and then provide accurate response. Next, we have a chat function that actually communicate with the AI model. This function take our conversation history and send it to the AI. The AI need to remember our previous messages to understand the current request. The entire conversation is sent to the model. The AI process it and returns a response. Our function then take that response and give it back to the rest of the program. One important setting here is temperature. We keep it at 0 because when we are building an agent, we want a predictable behavior. If we ask the same questions multiple times, we want the similar results, especially when the agent is deciding whether to use a tool or not. Now come to the one of the most important part of the agent. A normal chat box can only generate a text. It can explain how to create a file, but it cannot actually create a file. A tool gives AI that ability to take that action. For our first tool, we are giving the access to bash commands. Bash is the way to communicate with the computer using commands. For instance, user can say, show me all files in this folder. AI understand that it needs a computer access. It creates a command saying, list the files. Our tool then run the command, the computer returns the results, and the AI explain the result to the user. This is the important idea behind agents. AI does not directly control the computer. AI decides what actions it needed. The tool performs the action and result come back to the AI. You will notice we use try and accept because computers do not always behave perfectly. Maybe the command is wrong. Maybe the file does not exist. Maybe something is unavailable. Without error handling, one small problem could stop the entire agent. Instead, we capture the error and send the information back. This allows the AI agent to understand what went wrong and possibly try another solution. Now we have reached the harness class. Think of harness is the manager of our AI assistant. AI is the brain, tools are the hands, and harness connects everything together. When we start the program, the harness creates AI connection, the available tools, and the conversation history. It is responsible for controlling the entire process. For instance, user can say, create a file called hello.py. AI does not directly create a file. Instead, it says, I need to use a bash tool. The harness send that request command to the tool. Tool creates the file, the results come back, and then AI tell the user your file has been created successfully. Finally, we have the starting point of our application. This is where we tell Python, when this file runs, start AI assistant. The program creates our harness. Harness prepares AI model. Then it loads tools and create the conversation and start listening to the user's request. In simple words, this is the power button for our AI assistant. Everything we created earlier comes together and start working as one system. Let's test our agent now. When we run the first cell, we get a warning that this notebook is not authorized by Google. Click on Run Anyway to continue. Let's type hi to check the AI model, and we get the successful response that our Nexa agent is ready. Next, I ask which directory I am in. And notice, we asked LLM, but it used the tools and gave me the correct answer that we are in content directory. Next, I ask list all the files in this folder, and it gives the correct result without any issue. Next, I ask create a file inside the sample data folder and give a Python function to add two numbers, and it creates the file successfully. Then I say add a new multiplication function inside the same file, and it amends the file without any issue. Now let's push it. I say describe the content of California housing train file, and it gives me that as well. Now remember, it is not using a RAG embedding yet, it is using a tool to find the content. I can also ask to create a new file with all this information, and it can create that text file without any issue. Now, if I ask to convert the text file into Excel, notice that it cannot convert the file to Excel. Instead, it says we need to import pandas library to do this, and it gives me a Python code. So then I say create this Python file and run it and convert the current text file into Excel. Now agent will run in a loop until the Excel file is created successfully. So in this project, we created the foundation of an agent. We connected to an AI model. We added tools. We created the controller, and we built a loop where AI can understand request, take action, respond with the result. This simple architecture is the foundation behind much bigger AI assistant. That's all from me. See you in the next one.